Hello, ladies and gentlemen. Welcome to the next installment of lesson on functions. Okay, we're going to be talking about composition of functions or composite functions. Composite function is a function within a function, or another way we can look at this is using the output of one function as the input of the next function. So this is a topic I believe you've all covered in Algebra 2 Trig. So we're going to do a little review. So let's look at the example we have. F following g of x, that circle here that I'm pointing to, means following. So f following g of x, we can also write it here of f of g of x. So let's look at this. We have two functions. We have the f of x function, 2x squared minus 3x plus 8, and our g of x function of x minus 6. So to find the composite, we need to substitute the g of x function, the x minus 6, into the f of x function. So everywhere where we see an x here, like this x that's squared, and the x with the negative 3, we need to put the x minus 6 in parentheses with that. So that's what I've done here as the first step. So f following g of x, 2 parentheses x minus 6 squared, minus 3 times x minus 6 plus 8. So, as it says in the box here, I've substituted the g of x function into the f of x function. So when I do that, and I multiply x minus 6 times x minus 6, you get x squared minus 12x plus 36. There's a 2 out in the front, so I drag that along. Then here I distributed this negative 3, and that's how I got the negative 3x, the plus 18, and then don't forget to drag that 8 along with you. So the next step, order of operations, we're going to distribute the 2 to get 2x squared minus 24x plus 72 minus 3x, and then I took the 18 and the 8, combined them to get 26. So when we're all done, f following g of x is 2x squared minus 27x plus 98. So if you need to take a minute to pause the video at this point and go over what we've done, or even rewind it if you have to, do that. I'm going to be moving on. Let's look at another example. We're looking at the same two functions. 2x squared minus 3x plus 8 is f of x, and g of x is x minus 6. Now this one, if you see, it's reversed from the previous one. This says g following f. So I'm going to take this function, 2x squared minus 3x plus 8, put it into the g of x function where the x appears. So we have 2x squared minus 3x plus 8. Don't forget to drag this negative 6 along with you. Combine your like terms, and that's what you get. Typically, we see evaluating a function for a particular value. Well, this one is g following f of 3. So the first thing we need to do is find out what f of 3 is. So what I did is took the f of x function from above, substituted 3 in for x. So 3 squared is 9, times 2 is 18. Negative 3 times 3 is negative 9, plus 8. Combine like terms, you get 17. So f of 3 is 17. That becomes the input into the g of x function. So now we take the 17 and we evaluate g of 17. So where the x was, I put the 17. So g of 17 is 17 minus 6, or 11. Again, if you need to pause this and go back over it again, do that now. Another thing we're going to look at today is the inverse of a function. When you take the inverse of a function, you swap the x and the y, then resolve it for y. So we have this function y equals 3x squared minus 5. First thing I do is I swap the x and the y. So where the y is, I put an x. Where the x was, I put a y. Then we have x is equal to 3y squared minus 5. So I need to resolve this for y. I need y by itself. So I add 5 to both sides, and I have x plus 5 is equal to 3y squared. I divide both sides by 3, and I come up with x plus 5 over 3 is equal to y squared. I solve for y by taking the square root of both sides, and we find that y is equal to the square root of x plus 5 over 3. So again, on the inverse of a function, you swap the x and the y and resolve the equation for y. Let's look at a couple of examples, some practice questions. Here's your f of x is 2x plus 5. Your g of x is 3x squared. F following g of x, that means I'm going to take the 3x squared and put it into the first function where the x appears. So I have 2 times 3x squared. Don't forget to drag the 5. 3 times 2 is 6, x squared plus 5. Part B, we're going to be doing this in reverse. Put in the 2x plus 5 into the g of x function where the x appears. So we have 2x plus 5 squared and 3 sitting out in the front of the parentheses. So first we'll multiply 2x plus 5 times itself, and you get 4x squared plus 20x plus 25. Remembering the 3 out in front. We now multiply by 3, and you have 12x squared plus 60x plus 75. Now let's look at f following g of 2. We need to evaluate g of 2 first. So you put the 2 where the x is. So you have 2 squared is 4. 3 times 4 is 12. That becomes the input into the next part of the function. So we will evaluate f of 12. So 2 times 12 plus 5. 2 times 12 is 24 plus 5. So the answer is f following g of 2 is 29. Another example, another practice problem, excuse me. F following g of x. That means we take the x minus 3, wrap it in parentheses, and put it here where the x appears. So I did that. X minus 3 squared times 3, and remember I had to drag that 4 with it, the minus 4. X minus 3 times x minus 3 is x squared minus 6x plus 9. Remember, we're dragging that 3 that we dragged, multiply everything by 3. Don't forget to subtract the 4 at the end after you've done distributing the 3. Final answer is 3x squared minus 18x plus 23. G following f of x. We're going to take the 3x squared minus 4, put it into this function where the x appears, and you have 3x squared minus 4 and then minus 3. Cleaning it up, you have 3x squared minus 7. For the last one, we have g following f of 11. So we have to evaluate f of 11 first. So 3x squared minus 4. 3 times 11 squared minus 4. 11 squared is 121. So 3 times 121 minus 4. So you have 363 minus 4, or 359. That's f of 11. Now we have to evaluate g of 359. So in place of the x, I put 359. So we have 359 minus 3 is 356. So g following f of 11 is 356. Again, if you need to stop at any time and rewind and listen to it again, you should be doing that if you need to. Let's look at one last practice problem. Let's look at the inverse of a function. So you're given the function of y plus 3x equals negative 1. So we swap the y for an x and the x for a y, and you have x plus 3y equals negative 1. Subtract x from both sides, and you have 3y is equal to negative x plus 1. Divide everything by 3, and y is equal to negative x minus 1 over 3. So ladies and gentlemen, that is the end of the composition of functions lesson. Tomorrow in class, we'll be doing a lot of problems to give you more practice with this. Thank you for tuning in.